In this video, we're going to talk about imaginary numbers. Now, so far in math, you've pretty much worked with what we call real numbers. Right? But now we're going to work with numbers that are not real. They're what we call imaginary. And before I actually define what imaginary numbers are, I want to show you kind of why we need them. And I want to do that by asking this question. What is the square root of negative 9? Right? Well, let's first apply our definition of what a square root is, right? Which is right here. And so if the square root of negative 9 exists, then the square root of negative 9 times the square root of negative 9 should be equal to negative 9. Right? So let's think about this. Do we know any number that would work here? Right? Well, maybe it's 3. Is 3 times 3 equal to negative 9? Nope, that's not true, because 3 times 3 is positive 9, so that doesn't work. Right? Well, maybe it's negative 3. Let's try that. Negative 3 times negative 3, is that equal to negative 9? Nope, again, right? Because negative 3 times negative 3 would be positive 9, so that's not true. Right? So it turns out that there is no real answer to this. Right? We can say there is no real answer. Right? And so that's why we need to have an imaginary answer, an imaginary number. Okay? All right, so I'm going to actually show you what imaginary numbers are. And it all starts by asking this question. What is the square root of negative 1? Right? And similarly to what we did on the other page, if the square root of negative 1 exists, then by its definition, the square root of negative 1 times the square root of negative 1 must be negative 1. And just like on our previous slide, there is no real answer to this, right? 1 times 1 is not negative 1, and negative 1 times negative 1 is not negative 1. So it seems like there is no answer to this, right? Well, that's where imaginary numbers come in, right? And what we do is we define what an imaginary number is, right? And mathematicians define the square root of negative 1 as the number I, right? So mathematicians use this category of imaginary numbers, and it's all based on this fact here, that the square root of negative 1 is defined to be the number I. Okay? And so this is what all of the imaginary numbers that we're going to talk about is based on. Okay? Something else that's kind of interesting here, right? If we know this definition, the square root of negative 1 is defined to be I, there's something interesting here. That would mean that I times I is negative 1, which also means I squared would be negative 1. These two things are the most important facts, right? Square root of negative 1 is I, which in turn means that I squared is negative 1. And just I had this one more time so for you to see it. Right? All imaginary numbers, it's all based on this fact. Square root of negative 1 is I, and I squared is defined to be negative 1. All right, so we're actually going to get to some problems using imaginary numbers. But first, there's one other thing we have to remember. It's the multiplication property of square roots. And it says this. The square root of a times b is equal to the square root of a times the square root of b. And this is always true unless both a and b are negative. If one of them is negative, this works. But if both of them are negative, we can't use this. Okay, but we will use this a lot. All right, so let's go back to this problem that we asked in the very beginning. What's the square root of negative 9? Okay, and then what we can do is we can show how to simplify this. Okay, and you may remember doing what are called factor trees with this, right? And what we're doing is breaking negative 9 into its factors, right? Well, first of all, I could say that negative 9 is the same thing as negative 1 times 9. And then I could say that 9 is 3 times 3. Okay, and this shows me what the factors of negative 9 are. Okay, and that helps us to simplify this. Here's what we're saying. What we can see now is that the square root of negative 9, by that multiplication property, is the same thing as the square root of negative 1 times the square root of 3 times the square root of 3. And let's see if we can simplify this. Right here, what's the square root of 3 times the square root of 3? Well, by definition, that has to be 3. And then the square root of negative 1, what's that? That's not a real number. That's an imaginary number. That's what we called I. So the square root of negative 9 is I times 3, or we will write this as 3I. Right? This is an imaginary answer. We call that imaginary answer 3I. Okay? I also want you to be familiar with how this technique works with a real number, like the square root of 24, right? This is not a perfect square, right? So this is going to be slightly less than 5. But let's show how we can simplify this with the factor tree, okay? And you probably remember doing this in the past, right? But I really want you to understand why this works, okay? Let's use a factor tree to break this down. So the square root of 24 would be, let's break this down into factors 4 times 6. And then I could break down 4 as 2 times 2. I could break down 6 as 3 times 2. Right? And so what I have here, and I'm done because these are all prime numbers. Okay? So what we've said, basically, what's the purpose of that factor tree? That factor tree shows us that the square root of 24 is the same as the square root of 2 times the square root of 2 times the square root of, let's put them in orders, square root of 2 times square root of 3. Right? And let's see if we can simplify this. Well, what's the square root of 2 times the square root of 2? Well, by definition, that is 2. And then we can still simplify this. That multiplication property tells us square root of 2 times the square root of 3 would be 6, or a square root of 6. So this would be 2 radical 6 is my answer. Okay. All right. Let's do one more, and then you're going to try some on your own. So let's simplify the square root of negative 40. Okay. Now, first, notice that since this is a negative, that means this is going to be an imaginary answer. Okay. So when I break down my factor tree, I'm going to break this down as negative 1 times 40. 40, I can break that down as, let's say, 4 times 10. 4, I can break that down as 2 times 2. 10, I can break that down as 2 times 5. Okay? Again, what's the whole point of this factor tree? The whole point of that factor tree is to show us that the square root of 40 can be rewritten as the square root of negative 1 times the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5. Okay? And now, let's simplify this. All right? Square root of negative 1. That, by definition, is the number I. Right here, square root of 2 times the square root of 2. By definition, that has to be 2. And then right here, radical 2 times radical 5. Using the multiplication property, that would just simplify to be radical 10. Okay? All right. The way we will write this answer is like this. This is the order that mathematicians write this in. The answer to the square root of 40, what is that simplified? That is 2 times I radical 10. Okay, 2 times I times radical 10. And we write that like that, 2I radical 10. Okay. Now, you might think that's kind of weird, that the square root of negative 40 is equal to this. Right? Well, let me prove to you that this works. Okay. So, if I were to use the definition of the square root, right, what does that mean? Well, that means the square root of negative 40 times the square root of negative 40 has to be equal to negative 40. And I want to prove to you that this weird thing here, 2I radical 10, in fact is the square root of negative 40. Right? Well, let's think about this. Let me show you that this works. If I do 2I radical 10 times 2I radical 10, I will in fact get negative 40. Now watch. Let's rearrange this. This would be 2 times 2 times I times radical 10 times radical 10, and this will get me 40, negative 40. Right? Let's see. 2 times 2 is 4. I times I is I squared. Radical 10 times radical 10 by definition is 10. Now if you go back to one of our earlier slides, we talked about this fact. I squared is -1. So 4 times -1 times 10, that's -40. Right? So I've just shown you proof that this 2i radical 10, because we can use imaginary numbers, is the square root of -40. Lastly, I would like you to try these two out on your own. Simplify these, and then we'll check and see how you did with this in class tomorrow.